represented by this. Again, 3D Mohr circle can be represented by what? So X, Y, and Z all fall in the circumference of the line. And I like to get your attention over here. Over here, this is our stress max. And over here, this is our stress mean. Okay. And this is also can be known as stress 1 and stress what? And stress 2. From here, we know that stress 1 and stress 2 are known as, anyone? Are known as what? Principal stresses. Can you tell me what's so unique about principal stresses? Anyone, please? What's so unique about principal stresses? Yeah. For this case, in the principal stress direction, shear stress is equal to what? 0. Now, this over here is acquired from what? Mechanical what? Testing. Okay. Now, have you ever wondered why the maximum shear stress criteria is stress max divided by 2? I repeat again, have you ever wondered why the maximum shear stress equals stress max divided by 2? This is all to do with what? Mohr circle. Listen, do not memorize anything of this. Mohr circle is a mechanics fundamental. Are we clear? Draw the circle, you'll be fine. Do not memorize any of this. Am I looking at any textbook? No. You should do the search. Are we clear? Okay. So now, why stress the shear max is equal to stress max divided by 2? Now coming back to the circle. Coming back to the circle, this over here is our what? Can anyone give me the formula for tau max by looking at the circle? Anyone? Yes. Yeah. Stress max divided by what? 2. Yes or no? So this is where we call this what? Tresca criteria. By just looking at the what? By just looking at the circle. Okay. Can you all see how I spell Tresca? Tresca is to spell with what? A T. Can you see how I write the T? What is that symbol? Tau. Tau to remind you that is what? Under shear. Are we clear? Okay. Tricks like this, you will never go wrong. Okay. Right. So now we know our tau max. Okay. So this can be also equal to our tau liak U. So what did we learn from all this? What we learned from all this is this. Over here, what is listed down here are all your what? These are all your principal stresses. Now you look at the table, you know what it actually means. Not randomly like, maximum normal stress. What sort of normal stress? Maximum principal stress where there's no what? There's no field. Are we clear? From here, so this is the data we get, and what we measure and what we formulate is known as what? Principal stress. Some of you might tell me, Eugene, why is it known as principal stress? So if you watch this figure down here, if you watch this figure down here, this is your what? Stress X. Your stress X at point X over here happens to be your what? Your principal stress, where your shearing stress is equal to what? Equal to 0. Okay. From here, we are going to look at our analysis. Okay. So our analysis is we have a diagram over here. This is from our analysis. Right? So this is from our structure analysis. So from here, we know that stress Z is equal to, I can't remember now, mx over Ixx multiplied by y, and you have a shear Zy is equal to Vy over I can't remember now. I do beg of Ixx Qx over T. That's how we compute that. So from here, we also now have to sketch what? A 3D what? Whole circle. Okay. So this is our point over here. This will be our point Z. Over here will be a point X. And over here is our point what? Or point 1. So now we're going to sketch 3D mole circle. Okay. So from here, again, we start drawing what? Mole circle. Again, don't worry if you cannot remember. I will start from ground zero. Okay. So I'm going to focus on the tension part. Okay. So this is stress X, or this is normal stress, shear stress, element rotating clockwise, shear stress, element rotating anti-clockwise. This is our zero. Okay. Oh, shoot, I draw it as compression. I have to move the other side. I beg your pardon. Right. So from here, I'm going to have my stress Z. So this is my stress Z. Stress X and stress Y are zero. So stress X and stress Y are on the zero line. Then we have our shear. We have our shear. Okay, and I'll teach you all later on. Okay, stress X element will rotate clockwise. Don't worry about this. I will teach you all later on. This is your point Z. Over here will be your point Y. And over here will be your point X. Point X is exactly at 0. It's because you have 0. Here. Now we construct 3D mole circle. So how does 3D mole circle look like? Okay, so I know for the fact that the center, this is our stress average. And then we can construct our circle. I will use a different color. I will sketch a circle now. Okay, so this is one of the circle. And then another circle. It's not that important, but I want you to show you there's 3 circles. So this is the next circle over here. Okay. And then the last circle will be over here. This is our last circle. Yeah. So this is the 3D Mohs circle. Here. Okay. So from here, what is so critical? Okay. There are two sets of points. So this is from our analysis. So this is our 3D Mohs circle. So we know that we can draw a line across here. Okay. So now, what's so critical about this now? Okay. There are 2 points over here. So for this case, you have a point down here that is known as stress A. And there's another point over here that known as what? Stress B. Okay. And stress A and stress B the stress A and stress B are the what? Principal stresses based on the what? Analysis. Stress A and B are the principal stress based on the what? Analysis. Not based on what? Material property. So stress A and stress B are the principal stresses. So therefore, the shear stress is equal to what? 0. So to select material or determine the factor of safety, what we must ensure, so the factor of safety is equal to stress max divided by stress A, or factor of safety is equal to stress mean divided by stress B. Why is that? Right? I'm going to make this a bit untidy so you can see better. Eugene, you're not making sense. I'm going to make this untidy so you can see better. Stress max is over here. Stress A is over here. We are comparing stress A that has 0 what? Are we clear? This is how we calculate factor of safety and what? Determine the type of material. Are we clear? Does it make sense now? Because why? What have we done with Mohs circle? Mohs circle, basically, we know that there's shear at point Y and point Z. We know that. But in this context, in this circle, there are also what? Principal stresses. And the principal stress, the shear stress is equal to 0. And this is how you calculate or determine factor of safety. So in a nutshell, what am I doing to you now? In a nutshell, what am I doing to you? To know this in detail, Mohs circle will take about 2 weeks to learn Mohs circle, 3D Mohs circle. Shearing stress, will take about 3.5 weeks. Normal stress, this one you all done before, yes or no? You have confidence